So today we'll be learning about the chain rule, which is one of the most core concepts in all of calculus. And it is what you're going to need to use if you need to take the derivative of a function that contains another function inside. So let's say we have f of g of x, which is a compound function, and we need to take the derivative of that. So first we would take the derivative of the outside, so we have f prime of, and then we leave the inside as is, so f prime of g of x. Then the inside, g of x, we need to take the derivative of that and multiply that out in front. So we have g prime of x, and that is multiplied with the f prime of g of x. So let's say we have an equation sine of 2x cubed, and we need to take the derivative of that. So first we take the inside, and we take the derivative, multiply that out in front, and we have 6x squared. Then this derivative of the outside function sine is cosine, and then we take the inside as is. So we have cosine of 2x cubed. So even something simple, like if, for example, if we have 2x plus 1 whole squared, we also need to take the chain rule because the 2x is also an outside function. So you can't simply just do the power rule and get 2 times 2x plus 1. We also need to take the derivative of the inside, 2x plus 1, and multiply the 2 out in front. So now my teammates will work through another few examples with you. You should pause the video if you want to work it out yourselves, or you can do it alongside them as well.
For our first problem, f of x equals 6x squared plus 7x to the fourth. First, we should separate the inside and outside functions, x to the fourth and 6x squared plus 7x, and input them to the chart as such. We will then take the derivatives of the two and combine them, which will give us f prime of x equals 12x plus 7 times 4 times 6x squared plus 7x cubed, in parentheses, times 6x squared plus 7x cubed in parentheses.
So we are going to be finding the derivative of the equation y is equal to 2x squared plus 5x plus 1 whole cubed. And we will be using something called the chain rule, where we have a function inside of another function. So in this case, the inner function is 2x squared plus 5x plus 1, and we'll just equal that to u. We'll assume it to be u for now. And then that would just make the outer function y is equal to u to the power 3. And we will use the power rule to take the derivative of the outer function first. So using the power rule, d over du times u to the power 3, that would just be 3u squared. And then we will plug in the actual value for u, which would just be 2x squared plus 5x plus 1. So we'll write that down. And then now we'll take the derivative of the inside function, which is like just the derivative of 2x squared plus 5x plus 1. And that would be 4x plus 5. And now we have to put it all together using the chain rule. Actually apply the chain rule. We would write dy over dx is equal to 3 times 2x squared plus 5x plus 1 whole squared times, in brackets, 4x plus 5.
Next up we have f of x equals sine cubed of 2x. To separate the inside function and outside function, we would separate it to x cubed and sine 2x. Now this would be a double chain, so we should separate it again to sine x and 2x. We will then input both of those into the chart, and we will get the derivative of sine 2x being 2 cos 2x. We will then plug that into the first chart, which will give us the derivative to f of x being f prime of x equals 3 sine squared 2x times 2 cos 2x.
Move on to the next two problems, which are definitely a lot more difficult. So first, we have sine squared of 2x cubed plus 3x. So first, it's another double chain rule. So the first outside function is the squared, x squared. The second outside function is the sine. And then finally, the inside function is 2x cubed plus 3x. So if we take the derivative of the first outside function, we have 2. The exponent goes away. And then we have sine of 2x cubed plus 3x. Then we take the derivative of the inside function, sine, We take that out, and that multiplies a cosine 2x cubed plus 3x. And then finally, we take the derivative of the main inside function, and that gives us 6x squared plus 3. If we multiply everything out, we get 12x squared plus 6 times cosine of 2x cubed plus 3x times sine of 2x cubed plus 3x. Now, the last problem, we have the square root of the natural log of 5x squared plus 1. So first, let's reorder it to make it a bit easier to solve. And it's now natural log of 5x squared plus 1, all to the power of 1/2. That way, we can clearly see that the power of 1/2 is the first outside function, the ln is the second outside function, and the inside is 5x squared plus 1. So obviously we take the derivative of the outside, the 1/2 comes down, and the exponent turns into a negative 1/2 with ln 5x squared plus 1 on the inside. Then we take the derivative of the second outside function, and the ln turns into a 1 over x, so we multiply by 1 over 5x squared plus 1. And then finally, we take the derivative of the final inside function, and that's 10x. So if we manage to multiply all of that together, we get 5x over the square root of natural log of 5x squared plus 1 times 5x squared plus 1.